YouTube channel Knowledge Star Continuous Knowledge Excellence. My name is Karuna Singh. In this video, we will get to know about the PDT response singlet oxygen detected through DPBF consumption. Now, our expert, Professor Himadri B. Bohidar, who is associated with National Center Excellence in Agro Nanotechnology, Delhi Daikin Nanotechnology Center, India. He has 31 years of academic experience in teaching and research. His area of expertise includes nanoscience and nanotechnology, nanobiointerface science, soft matter science, polymer physics, biophysics. Will explain you in detail about this topic. So to get complete information, watch full video without skip.
Now, how do you know that the reactive oxygen species have formed? What happens is you expose the nanogels, which is containing the CE6 now, to a radiation, which is a laser light operating at 655 nanometer, 25 milliwatt laser light for different durations of time here. And then when we do this, the CE6 will absorb the photo energy and create reactive oxygen species there inside the medium. Then we need a probe molecule which is conventionally DPBF, which is diphenylsobenzene furan, which is typically used in testing how much singlet oxygen species have been developed. So what happens is this molecule gets oxidized in the presence of O1, singlet oxygen, O12 here. This is this DPBF molecule. This gets oxidized very strongly with this and changes the structure to this one with time. So the concentration of this changes. So if you just look at a UV visible spectroscopy data, this is what you will see. With time, as more radiation is given to it, more ROS species are created, more of 1O2 will be created, more of this will get reacted, and their concentration will drop. This is what you see, concentration dropping here. If you increase the duration of the radiation, lower is the amount of DPBP present in the solution, which proves that singlet oxygen species have been created. The same data here plotted in a normalized manner, but the information content is basically same. Now, if you want to see the drug release from there, where we put SAHA, which is the drug there, and this is released over a period of time.
Wait. Are you worried about your project, training, dissertation, internship? Don't think too much, because Nanoscience and Technology Consortium, in short NSTC, is giving you a golden opportunity to do the same tasks. NSTC also conducts workshops on amazing topics. So if you want to register in the workshop, the registration link is given in the description box below, or you may go to the website www.nanoschool.in, where you can easily enroll in the workshops. So just check it out right now.
And now this is the stimulus that has been used here is GSS, is glutathione. So when the singlet oxygen species, ROS, are created inside the system, then that affects your GSS molecule, glutathione, and which stimulates the release of SAHA from this matrix of the gel. And this is what you will see here as a concentration for free SAHA. This is the release, burst release here. There is no regulation here. Everything is released. No glutathione there in the nanogel system. Sub release is there, but then it's not regulated after a while, after 5 hours or so. But when it is present inside the nanogel and with glutathione there, then this is more prolonged and slow release. Initial, there's a large release, 60, 70%, 80%, then it last 20% is released over a longer period of time. So the release is much more sustained when we use a nanogel platform for release of this drug in in vitro testing process. Now this is the cell viability data. This is immediately 0 seconds. Then you see the control here, only CE6, nothing changes. SAHA, almost the same. CE6 plus SAHA, it's almost same. Nano and CE6, same. And this is marginally smaller. But after a while, you see that there is a drastic change. And when you are delivering it through the nano CE6 Saha, the viability is much, much less. And in fact, 20 seconds is drastically reduced further. So this now shows the efficacy of the nanogel drug delivery system when it is triggered through laser light, formation of reactive oxygen species, and then on to release of the drug. Now this, you see this size of the tumor in the beginning. This is with the control, this is the size of the tumor. When only Saha is used, there slightly reduces, but not much. With only CE6, more or less the same volume retains. CE6 irradiated with laser light, marginal change, not much. CE6 with Saha irradiation, comparable size, nothing drastically has changed. With nanogel CE6, situation remains more or less the same. When you use CE6 inside the nanogel and light, changes marginally, reduces definitely. But when you use it with the inhibitory drug Saha, CE6, light kept and all inside the nanogel delivery mechanism, this change is remarkable. Compare this with the starting point here. It's a considerable reduction when the platform is a nanogel platform, because the bioavailability of the molecule is much, much larger there. The same thing plotted in the numbers, how the tumor volume has changed over a period of time. Okay, so now the summary of what I told you just now is, by using CE6 and using a photodynamic therapy protocol, we capture the radiation energy to change it to chemical energy by producing reactive oxygen species. Reactive oxygen species help in triggering the release of the inhibitory molecule Saha from the core of the nanogel, and that acts on the tumor, and the signaling pathways are blocked. The possibility of tumor proliferation and revival gets drastically reduced. So this gives you a pathway for the application of this platform for management of cancer treatment when we are using PDT as the protocol.
I hope you like this video. Now, I would like to give you an important information that Nanoscience and Technology Consortium, or NSTC, organized the nanotechnology workshops on very amazing and interesting topics. Also, I would like to tell you about the initiatives of NSTC in which you can also be a part of. 1. Mentorship, patent commercialization, joint product development, research projects, consultancy services, nanomaterials for your research projects, training programs, customized training programs, workshops or customized workshops. So yes, that's all. If you want to see these type of informative and educational videos, so please do comment. We will definitely reach out to you. So subscribe to the channel Knowledge Star and hit the bell icon to never ever miss an update. Thank you everyone.
For more updates, subscribe to our channel, click the links shown on the screen to stay connected.